All available experts, please report to room A9.
Hello guys, Exeter here. The mechanical noise you heard is AND or AND. So A, right arrow, N, left arrow, D. So the stage collection from this module is very simple. You just evaluate the logic statement with the given logic gate on these two bits of binary to get your initial numbers. I should really leave them in binary for now, but once we've finished all the stages, I'll show you how to convert them into stage numbers. The logic gates used are the classic ones like AND or XOR, NAND. But unlike in my M&N's tutorial, we also have left and right implications. Basically, all you need to know for left implication is it only returns false if it's 1, 0. Right implication returns 0 or false when it's 0, 1. That's all you need to remember. So let's just collect the stages now. So we're starting with this with a left-right arrow. This is X NOR. Returns false is exactly 1 input is true. So taking these, if exactly 1 input is true, we're going to put 0. If both or neither are true, we're going to put 1. So we've got 1, 1, 0, 0, 1. Things to note, it might sometimes show this, which is a not. You can completely ignore the bottom bit of binary for this one. You just invert the top one.
Emergency cleared. All
so
personnel, please return to your stations.
Another X NOR. So we have 1, 1, 1, 0, 0. Because match, 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 not match, not match. Right implication. So if you remember, 0, 1 is the only time you will put 0, so 1, 1, 0, 1, 0. Or either has to be true. So in this case, we have since all of them have at least 1, 1, this is going to be fully 1s. Have another right implication, so 1 zeros are zeros, so we have 1, 1, 1, 0, 1. We have left implication, so we have 1, 0 being 0 now. So we have 0, 1, 1, 1, 0. This bar is NAND. If all inputs are true, we put 0, otherwise we put 1, so don't match as a 1. These next two matches as matches 1s, so we're going to put 0. And then we've got 1s for the last two as well. Next we have another right implication, so 0, 1s are zeros. So 0, 0, 0, 1, 1. And both has to be true, so only this last one's going to be a 1. X NOR, exactly 1 has to be true, but not both. So again, only this last one applies. So I didn't get to show off some of these. We have NOR, which is just basically, it's only 1 if it's a 0, 0. Not if we were given, let's take the bottom one here. No, not would just be taking this and flipping all of the digits, basically. So 1s becomes 0, 0 becomes 1s. So let's solve this one. And notice, before we convert to numbers, let's convert these into decimal numbers. So we have 25. We have 28. 26. 31. 29. 14. 19. 3. 1 and 1. So how do we convert these into stage numbers? Because as you can see, there are only 10 stage slots. It does scroll down, but we're not going to be inputting 2-digit numbers here. We're going to be inputting 1-digit numbers. So how do we get these 1-digit numbers? The rules for doing it alternates between each stage. As you can see, if the stage number is even, so stage 2, stage 4, stage 6, we're going to be modulating by 10. On the odd stages, we're going to be taking the digital root of the number, so basically it loops between digital root, modulo, digital root, modulo, and so on. So let's follow this. So digital root of 25 is 7, 28 modulo 10 is 8, digital root, mod 10, digital root, this is becomes 11, digital root is 2, modulo is 4, digital root becomes 10, which is 1, modulo is 3, digital root is 1, modulo is 1. So this is what we're submitting. So we have 7, 8, 8, 1, 2, 4, 1, 3, 1, 1. And we have a solved boss module. This always flips between digital root, modulo, digital root, modulo, and so on and so forth. So, recap. Apply logic gate to the two strings unless it's a not, then invert the top string. So say 11010 will become 00101. Convert them to decimal and then convert them into single numbers by having the odd stages be digital roots and the even stages be modulos. And then type that in as the final sequence. This is a slightly more simpler boss module, but still can cause some errors if you forget the flip back and forwards, or you mess up one of the flips and you had to redo all the rest of them again. But other than that, hopefully you understand how to do A and D and A arrow D, N arrow D, or whatever you want to call it. And I'll see you guys in the next tutorial.